Hi everyone. In today's lesson we're looking at Chapter 8, Section 6, Proportions and Similar Triangles. Our objective is to use proportional theorems to calculate segment length. We start with Theorem 8.4, Triangle Proportionality Theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. That is, if line segment TU is parallel to line segment QS, then you can write a proportionality statement that RT, which is this length, and TQ, which is this length, is equal to RU, which is this length, over US. Remember that proportionality does not necessarily mean that the triangle is cut in half. It just means that they are growing at the same rate, or the ratios are the same on each side. Theorem 8.5, converse of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. If RT over TQ is equal to RU over US, then TU, which is this line segment over here, is parallel to QS, which is this line segment over here. Example number 1, finding the length of a segment. What is the length of line segment NR? NR is this line segment over here. Since I have two parallel lines, then I know that this little triangle MNP is similar to triangle MRQ. So I can write a proportionality statement that says that line segment PQ, which is this line over here, over MP, which is this line over here, is equal to line segment NR, the one that we're looking for, over MN, and that's using theorem 8.4. Once I write my proportionality statement, then I can just fill it in with the information I know and what I'm trying to find. I know that PQ is 4, I know that MP is 6, NR is what I'm looking for, and I know that MN is 9. Cross multiply, and you get 4 times 9 is equal to 6 times NR. Isolate NR by dividing every side by 6, and so you get 4 times 9, which is 36. Divide that by 6, and we get that our answer for NR is 6. So the length of line segment NR is 6. Alright, checkpoint problems number 1 and 2 are yours. In problem number 1, find the length of line segment DF. In problem number 2, given the diagram, determine whether line segment MN is parallel to line segment PQ. Theorem 8.6. If three parallel lines intersect two transversals, then they divide the transversals proportionally. Remember, proportionally does not always mean it's divided in half. It could be 1/3, it could be 3, it could be 2/3. It just means that the ratios is the same on each side. So, if R is parallel to S and S is parallel to T and L and M intersect R, S, and T, then we can say that UW, which is this line segment over here, over WY, which is this line segment over here, is equal to VX, which is this line segment over here, over XZ, which is this line segment over here. Theorem 8.7. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the length of the other two sides. If ray CD, which is this ray over here, bisects angle ACB, then you can say AD, which is this line, over BD, which is this line, is equal to CA, which is this line, over CB. That means the ratios of these two sides are the same. Example number 2, using proportionality theorems. What is the length of line segment GH? GH is this line over here. Looking at these angles, notice how these angles are on the same side of these lines, which means that these angles are corresponding angles. And because we know corresponding angles are congruent, the lines are parallel, which means we can use theorem 8.6 to find the length of GH. Theorem 8.6 says that if you have lines that are parallel, then the transversals divide the lines proportionally. So we can write our statement of FG over GH is equal to JK over KL. Once I write my proportionality statement, just fill in what I know. FG I know is 28, GH is what I'm looking for, JK is 30, and KL is 25. Cross multiply and you get 28 times 25 is equal to 30 times GH. 28 times 25 is 700. Isolate GH by dividing both sides by 30, and you get 700 divided by 30, which you can simplify, divide both these by 10 to get 70 over 3. So GH is 70 over 3. You can either write it as an improper fraction, 70 over 3, or you could write it as a mixed number, which is 23 1/3. Or you can also write it as 23.33. Repeating. Example number 3, still using proportionality theorems. In the diagram, angle QPR, which is this angle over here, is congruent to angle RPS, which is this angle over here. Use the given side lengths to find the length QR. QR is this length over here. Because line segment PR is an angle bisector of angle QPS, and we know it's an angle bisector because these two angles are congruent, then we can apply theorem 8.7, which says if a ray bisects an angle of a triangle, then it divides the opposite side segments whose lengths are proportional. So let x equal QR, and then RS, which we don't know what the length of RS is either, but we know that if we were to find QR, we can find RS by taking the total length, which is 18, and subtracting x from it. So I can say that this length RS is 18 minus x. I can now write a proportionality statement of PS, which is this line over here, over QP, which is this other diagonal line, is equal to RS over QR. Once I write my proportionality statement, I can fill in with what I know and what I'm trying to find. I know that PS is 8. I know that QP is 12. I know that RS is 18 minus x. And I know that QR is x. Remember, anytime I have a quantity either on the top or the bottom of a fraction, I want to put it in parentheses so that I know when I'm cross multiplying, I am multiplying the quantity. So when I cross multiply, I now have 8 times x is equal to 12 times the quantity 18 minus x. Distribute to get 8x is equal to 12 times 18, which is 216, minus 12x. Add 12x to both sides to isolate the 216. 12x plus 8x is 20x, which is equal to 216. Divide both sides by 20, and we get 216 divided by 20, which is 10.8. So the length of line segment QR is 10.8 units. Example number 4, finding the length of a segment. A state park has 5 trails as shown in the diagram. The horizontal red, green, and blue trails are evenly spaced. So this is important, it's evenly spaced. The river and sky trails intersect the red, green, and blue trails. Explain why the distance between the red and green trails on the sky trail is the same as the distance between the green and blue trails on the sky trail. So we want to explain why this length BD is equal to this length DF, knowing A to C and C to E are evenly spaced from each other. So here's our solution. Because the red, green, and blue trails are each horizontal, you know that they are parallel to each other. Using theorem 8.6, which states that if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally, we can conclude that AC over CE is equal to BD over DF. Because the trails are evenly spaced, you know that AC is equal to CE. So these two line segments are equal. So you can conclude that BD is equal to DF, which means that the distance between the red and green trails and the green and blue trails on the sky trail have the same length. All right, checkpoint problems number 3 and 4 are yours. In problem number 3, in the diagram, line segment JK is parallel to line segment LM, which is parallel to line segment NP. HL is 2.4, KM is 2.8, and MP is 4.9. Find the length of LN. In problem number 4, find the value of x. All right, that's it from me. I'll see you all soon.